get started. Any questions on the, oh, we just finished up the homework. Any questions on that?
57, please.
Which one? 57?
Yeah, 57.
All right, we'll do 57, then we'll get going. There's only two parts?
Yeah, there's A and B.
Okay.
A is 0.
A is 0?
Yes. Everyone says.
And next.
All right, let R denote the reaction to a stimulus of strength X.
Not part.
Based on a scale from 0 to 10.
Yeah, I think
Estimate how salty the solution tastes. One relationship between R is given by... Oh, here we go. A is a positive constant, okay? And X is called the threshold, okay? Find R of X sub 0. Well, R of X sub 0 means you're putting in the initial amount for the X. So you have log of X sub 0 divided by X sub 0. The log of 1 is going to be 0, isn't it? Rx of 0 equals A times 0. So Rx of 0 equals 0. Nice. So far, so good? All right, for part B, find the relationship between R of X, which equals A log of X divided by X sub 0, and R of 2X. R of 2X. That equals A log of 2X over X sub 0. I can take the 2 that would be the written as A log. If I use the log laws, it'd be the vertical shift, so everything would be raised that many units. So if it's doubled, you're actually adding to shift everything up. That's how they're related. Does that make sense? Well, this is a product, isn't it? So I can, if I multiply expressions, I can add logarithms. Okay? I just didn't break it all apart. I could have written A log of 2 plus A log of X minus A log of X sub naught. But I wanted to leave these together. Okay? So that'd be a vertical shift of, that's how they're related. Okay? That's a good question. All right. And starting last section. Very exciting. That means finals are close. Have you guys all had your finals on 3 days? Or was any of you ever here on the 2-day finals? Okay, always have them 3? Okay. All right. We used to have 2 days for finals. It was awesome. I did. Anyway, I'll just have to raise it up this way, the old way. All right. So exponential and logarithmic functions. This is the last section. This is obviously going to be a lot of fun because I have 1, 2, 3, 4, 5, 6, 7 windows open. So I like to have more windows open. All right. Change of base formula. If U is positive and A and B are positive, everything has to be positive. We've already done this on the TI several times. It's the log of the expression divided by the log of the base. I told you there was a high school way of doing it. Log of U over log of B. That's using base 10. And the college way is ln of U over ln of B.
Why is the college way ln?
It's Greek.
Okay.
Just Greek. It was just a funny joke. Yeah, see, it's Greek. College, kids like Greek little bit more than high school kids. Is that true? Sure. Sororities, fraternities, all the Greek letters. Here are your FYI warnings before you tread through this section. Do not confuse the log of a quotient as the quotient of logs. It is not. It is the difference of logs when you have the log of a quotient. Okay? So don't get that confused. It's very easy to do so. And the next one, you cannot, well, you can't distribute logs or anything like that. If you had that, it has to be log of base A of U over B. No, it wouldn't.
No.
It'd be log of U base B. You're absolutely right. That would equal log base B of U. Okay? There we go. Okay, that's the change of base we just talked about up there. To punch it out and the log of a quotient. Anyway, I like the warning signs. They should put more of them in the books. Special change of base. We already said that was high school. We said this was college. This one is actually more calculus. Natural logs use a lot more in calculus than logs. It's easier to take the derivative of. In fact, the derivative, I can teach you calculus right now. The derivative of e to the x is e to the x. Somebody just tweeted that. Okay? All right, find the exact solution. That means no decimals. And a two-place decimal approximation. Okay? I think I'll do them two different ways. Don't you think that would be fun? Sure. Accessorize a little bit. Old school, and then the TI. Okay? I never had the TI option when I was an undergrad. Always wish I had. I never did. So old school, how do you rewrite an exponential equation to solve it? Yeah. Log base 4 of 3 equals x. You just rewrite it as a logarithm, and you would be fine. You can leave your answer like that. If you want to get fancy, you can write natural log of 3 over natural log of 4. You can do it like that. You know, that's fine. Somebody said, well, can't you just punch that out and get your decimal approximation? Sure you could. But that's not what I'm going to do. Rachel?
So is that the exact solution?
That is the exact. No decimals. We have fractions in it, logs, radicals, things like that. For the TI approach, I would take 4 to the x minus 3 as a function, and I would look for the x-intercept. I'll look to see where it equals 0. I see some wrinkled noses out there. Don't be wrinkling those noses. You never know, this might be a strategy that you might actually investigate someday. I'll close this window. I'll close this window. Hey, I'm knocking some windows down.
Look at that.
I know. I'm really doing well.
Oh,
I found it. And somebody's going to punch out, obviously, natural log of 3 and natural log of 4 and divide them. That's fine if you want. Y equals clear. Nothing as crisp and clean looking as an exponential function graphed out on a snowy, cold winter's day. Zoom 6. Nice. I will Google it. Second, calculate 0. Negative 5 to 5. Guess of 1. Points. Okay. Actually, the direction said find the exact value and a 2 decimal place approximation. Okay. So, I've satisfied both, and I did not check to see if one was the same as the other one. Now I can check them to see if I made a mistake in any such way. Natural log, is it 3 or 4? 3. Thank you. Divided by natural log of 4. I'm still cracking up over the frame. He wants to frame it. 0.79.
Oh, you want to frame in 0. You want to frame it?
Sure he does. He's an Ortega. All right, ready? Moving on. See, that's forever immortalized on this recording. They won't know whether it's Drew or Alex, though. All right, estimate this. We've done it for 3 days now, or 4. How do you estimate it? I'm going to go obviously the college route. Natural log is 0.5 divided by the natural log is 6. I'm not even going to graph it out. Natural log of 0.5 divided by natural log of 6. I think it said estimate. Okay, so it would be obviously the negative 3.68528.072. Nah, you can write down 3 or 4, probably 4 of them. There you go. Usually 4 decimal places for trig, 4 decimal places for logs, natural logs. That's probably pretty good. Oh, I might do through all this. Estimate without a calculator. How would I ever ask you to do this? On the 10 from 10, I'd say put away your calculators. It's that easy. I've done it before. I'll do it again. All right. 243 is 3 to what power? Sure you are. 3 squared. What? 5th it is. And using my powers of the log laws, I know I can drop the exponent out in front. The answer is 5. Perfect. Nicely done. That was, as long as you knew that 243 was 3 to the 5th. Yeah, you could use a tree. There are some things that you have to know and some things you don't, and these are one of the things you do. Like my final next week. I got this formula sheet from the math department chair from one of my geometry kids that said you can use it if you want. I'm not. I think you should know the geometric formulas. It's a geometry final. I mean, come on. I believe in no formula sheets ever for a final exam. This one, in this section, these are the most tedious and the most often asked questions on a final exam. This typifies almost the whole section. Can you solve this problem to the exact value? Using common logs means base 10. I usually take that part out and I use natural logs, but I'll use common logs today. And a 2 decimal approximation, So we're going to do both. Old school and on the TI. Old school is going to take a while. Probably just take the log of both sides, huh? All right. So the log base 4 of 2x plus 3 equals the log base 5 of x minus 2. Right, you drop these down, 2x plus 3. I like the exact value a lot better than the decimal on this one. It's got a little bit more style and character. I like old school answers versus decimals. But I like a lot of things old school, so 2x log base 10 of 4 plus 3 log base 4. Just distributing the logarithm through the parentheses. X log of 5 minus 2 log of 5. This shows some real skill depending on how your final answer looks. It's kind of like an art project. You know, you've seen art projects where some people just rush through it and got a bunch of jagged edges and doesn't look very refined. Then you see some people like, wow, that's impressive. That's what happens from here on out. You can tell the people that really have it versus the people that don't. For instance, like this 2, I get all the x's on the left or the right side. Which side would you like to do? Perfect. So I'd have x log base 4 with the squared minus x log 5 equals negative 3 log. Actually, I'd probably put that upstairs. Yeah, I probably would. Minus log 4 cubed minus log 5 squared. And now I'd obviously factor the x out. So x will be the log of 16 minus log of 5. I'm doing this really slow just for, not effect, but in case there are any questions. And I'd take the negative out. Log of 4 cubed, 64, isn't it? 5 squared is 25, plus log of 25. Yeah. Well, no. X times log of 16 fifths equals negative 1 times the log of, I don't know, 64 times 25. Even? I like that. Complicated? No, I like old school. That's fine. See, I would have punched on the calculator. I would have just done like 4 times 25 is 100, you know, and how many 4s are in 64? 1,600. That's probably what I would have done. But I didn't really have a whole lot of Oh, now I'm ready to divide, I think. Don't you think? What don't you think? Unless you want to get really fancy, but negative log of 1,600 divided by log of 16 fifths. Or you could put, well, let's just keep it 16 fifths. Isn't that a nice answer? I like that answer. Now everybody's ready for the... See, that's the difference between going somewhere, like taking the back roads versus the interstate. You learn more when you take the back roads, don't you think?
Well, now I know how to do it.
Well, yeah. Instead of like taking the interstate that we're going to do now. How would you do it if you were going to take the interstate on the TI? How would you punch it out? Somebody? Nobody? Oh, no. If I was going to punch it out, I'd take 4 to the 2x plus 3 minus 5 to the x minus 2. You have to have 2 unique approaches to check them in the end. See if you did it right. Does that make sense? You're like checking yourself. Huh? Yeah, I'm going to graph that and see where it equals 0. People use zeros for factoring all the time. I use zeros for graphing all the time. 4 caret 2x plus 3. Some people use a seed in the solver. I don't like that. 5 caret x minus 2. And then I'll get this decimal, and then I'll check them with both of them. Zoom 6. Oh my gosh, will it ever equal 0? Looks like it might be negative, huh? Second, calculate 0. I'll just go from negative 10 to 0 and check negative 5. Hey, there's one. It was hiding. Negative 6.34. I'm excited about the brain break today. It's like one of those Zen-like brain breaks. It is. All I have to do is check this answer for validity. And, yeah. Well, sure. Now I have to check. Second quit. Negative log 16. Does it work? Is it even close? It's not even close, is it? You can tell me the truth. It's okay. Is it really? Oh my gosh. Cars, is that great or what? Is that what you're telling them, how great that was? Excellent. Oh, is it time for a brain break or not? Is it? All right, this one's like Zen-like. You would, yes. This is going to be great. All right, and you, well, it's going to be awesome. You remember the kid with the red hair? I want you to try to do it as intense as he does it. Okay? I mean, you got to block everything out and just got to focus on your task. Okay? All right, you ready? Go ahead and stand up. Take it. I just read this like right before you walked in, like right after I graded the 0. All right. Put your hands together and clasp them. Actually, I think it was a different grip. I think it was like this. I think it was clasped this way. And then have it out in front, and you really have to methodically think about this to do it both directions. You're starting at the top of your favorite pretzel you've ever eaten, and you're tracing out the image going forward. Okay? A pretzel, have you ever seen a pretzel? Not a pretzel stick, an actual pretzel. You know that you go up and you go, oh my gosh. You know a pretzel?
Yeah, I got it.
Something like that, isn't it? Isn't that a pretzel?
You're too drawing angles.
I am. What is it?
No.
I wasn't too far away.
You got this, Zach.
Yeah, like that.
All right, there's your pretzel. Go ahead and draw it. Now, those of you wildly swinging your arms, you're not concentrating on your full range of motion. There you go. You're the kind of people who take a free throw and just chuck it up there without even thinking.
Yeah.
Probably.
Now you trace it one way, trace it backwards. Okay? Got it?
I want to see the redhead.
Good. Now, close your eyes and trace it forward.
Then backward.
And then, open your eyes, relook at the image, and now close your eyes and trace it backwards.
Oh, wait, never mind. I was thinking
I didn't say it was hard,
Oh.
but some people are just like, no. They're not like really thinking about it. There you go. You got to think about it. Good. That was it. I just read it. Look, I'll be the first one.
It's going to be some, like, big thing.
It was a Zen-like thing.
I didn't feel very zen-like.
Oh, actually,
I felt pretzel-like.
we'll do square breathing tomorrow. Remind me. Square breathing. We'll do that tomorrow, okay?
Square.
We'll do it tomorrow, I said. It's not a brain, well, it's sort of a brain break. All right, ready? All right, find the exact solution. Are you ready to do this one on your own? Are you ready? You can do this one easy on your own, can't you?
Sure.
So it's 2 to the negative x squared.
Yeah, 2 to the negative x squared. Most people don't like an exponent raised to an exponent, but you get used to it after a while. Exponents raised to exponents raised to exponents raised to exponents. You can keep going as high as you want if you want to.
Infinity and beyond.
Yeah, exponents and beyond. So, use, and then we'll do a 2 decimal. So, first approach, this one's not too bad. Log base 5 of 2 to the negative x squared, equals. Is it? You know what, I hope log base 5 of 2 negative x squared. Oh yeah, log base 2. I'm thinking of 3 things at once. I need to stop. That's a bad habit.
What?
Well, logarithms equal exponents, don't they? What's wrong?
That pencil got me out, dude.
Now take the negative
El calculadora.
And now, take the plus or the minus square root. It should be done. Thank goodness. Nobody said it yet. Good. Oh, somebody knew somebody was going to say it. You can't, it's not negative. It's an exponent. Look at this. Log base 2 of 5 to negative 1. So it just makes it 1/5. Log base 2 of 1/5. No, with logs, that's one thing I was getting ready to say is you have to be careful that you're taking the positive base and the positive expression, but negatives can show up other places. Right, that is, I'll be the first to admit that that's kind of a weird answer. And I might throw one out here after the graph, but maybe it'll be 2 places. Now, when I get a 2 decimal approximation, I'm not going to check this. I'm going to check it using a unique way of doing it. So I'll take 2 to the negative x squared minus 5, see where it equals 0. Yes?
So what's the actual answer? Is it root log 2 to 1?
These right here. That's my answer. Those are 2 answers? All right. I can't see the problem. Square breathing tomorrow. More Zen-like. 2 caret negative x squared minus 5. Now, I'm not sure, but I'm guessing the log base 2 of 5 is pretty small. I guess around 2 something. It doesn't show up anywhere? Nowhere?
It's imaginary.
Imaginary.
Yeah, I got imaginary one.
I don't have imaginary numbers for my solution. I plugged it in the calculator.
Now wait a minute.
So I got negative-
Y equals
I got
no place? What's the decimal approximation of this down here? Maybe I got a typo in my question.
1.523.
Negative second square root of log of 5 divided by log of 2. Is that what you got, Kyle?
Yes.
Good. Negative 1.52.
You have to take the law. It's just taking.
Wait, you didn't get it.
I got an imaginary number.
Why did you have negative root something?
Isn't the negative on the inside?
Oh, yeah, it is.
I thought we put it to 1.
Oh, it might come out to be imaginary. No.
No, put the negative on the outside.
Oh, I got an I.
Yeah. And the negative on the outside of the parentheses shouldn't be there.
Well, yeah, one's plus or minus.
So it's plus or minus 1.523.
Yeah, but if I do this, if I change this to 0.2, I guess it's going to come out to be still imaginary if I change it to 0.2.
Try it.
I am. It is. So there are no real solutions. I could keep my imaginary solution on there, plus or minus 1.523i. That would impress me if I was a teacher. Is there a typo in the question? Okay. I'm at college, not here. Are we about done? Which one is this? Find the exact, oh my gosh. You know what? Here we go. There you go, you right.
I'm right.
Yeah. I'm going to go hang out with the pink monkey for a while.
I want to hang out with Jennifer.
Quiet. Here we go. What do you don't know what to do?
I found this brought up in the chat.
What?
What?
You want the pad?
You can't remember what.
All right, there we go. All right, so it'll be log You float. You can put your hand on it. Your hand's on a magnetic conductor. You float the little tab above about a ½ inch, quarter of an inch, and then when you're ready to write, you press it, and it has to go up in the pen a little bit. You have to feel it. Sometimes it sticks. So, since you're dividing, obviously you can do what with the, whoa. Whoa. That's okay. You're fine. You're fine. Go with it. X minus, yeah, that's a big one. Minus 4. There we go. Divided by 3x minus 10. Perfect. And what's that going to equal? Very good. Equals 1 over x. Once you get the logs as a single log, yeah, once you, let me insert something in blue here, just a minute, Alex. Since I have space right here, I'll just write this as log of x minus 4 divided by 3x minus 10, since you're subtracting logs, equals log of 1 over x. And then there's my bigger one. So now you can drop the logs, kind of like when you drop the bases. All right, I'll go ahead and hook you back up with the red. There you go. Can you see the slide bar to go down, or you want me to do it? Okay, I'll do that. So now you can just solve, and now it's algebra. X obviously can't be 10/3. Just write regular. His arms aren't that long. He's going to use a tablet. Good.
I got it.
You did?
Yes.
Getting the hang of it. You were one of those quick pretzel guys, weren't you? There you go.
Is that a bracket?
Not bad for your first attempt. Good. So once you cross multiply, you get a quadratic. Now, one thing with logs, what do you have to check with? Right, you have to check for extreme or extraneous solutions. Also, you have to check to make sure that you take the log of a positive number. All these have to be positive. The 5 and the 2. The 2 won't work, will it? 2 minus 4, so that won't work. So the final answer is just going to be x equals 5. Okay? Good. Nicely done. Not bad. You get somebody else. Done.
We're done.
Well, let's try to get one more.
We're done.
Yeah, we better be done.
Yeah, please.
We're done.
1 through 19. Right there, right now.
All right.
Right there.
You need a pen. There you go. Go ahead and write in the page and the homework assignment. Page what?
Is that an R?
Page. All right, go ahead and slide it back over. Page what?
348.
348.
1 through 19.
1 through 19. Odd. Good. Nicely done.